SpaceX's Lunar Starship represents a pivotal evolution in humanity's quest to return to the Moon, serving as the human landing system for NASA's Artemis program, while embodying Elon Musk's broader vision for sustainable space exploration. Recent updates from Starbase in Texas underscore how SpaceX is accelerating preparations for this ambitious vehicle. With rapid infrastructure overhauls and advancements in the Starship lineup directly impacting lunar mission timelines. As SpaceX dismantles outdated facilities and assembles next-generation hardware, the path to deploying SpaceX's Lunar Starship becomes clearer, promising enhanced reliability for lunar landings and resource utilization. At the heart of these developments is the ongoing transformation at Starbase's launch pads. The demolition of Pad 1's orbital launch mount, as detailed in recent footage, highlights SpaceX's commitment to iterative improvement. Workers have systematically removed the upper shielding, booster quick disconnect components, and even structural elements like the drawworks roof and emergency stairs. This isn't mere cleanup. It's a strategic pivot to optimize for future iterations of the Starship system, including SpaceX's Lunar Starship variant. By repurposing materials, such as filling in the deluge runoff pond with berm wall dirt, SpaceX minimizes waste and adapts the site for more efficient operations. These changes ensure that pads can handle the increased thrust and thermal stresses expected from lunar-configured starships, which will require precise fueling and quick turnaround for multi-mission profiles. Pad 2's emergence as the new focal point further amplifies this momentum. The installation of vent covers, cover plates over bunker gaps, and the first purge tests of the top deck pancake system signal that the pad is nearing operational readiness. High-pressure gas and water tests kicked up dramatic clouds, verifying the integrity of water supply pipes, crucial for deluge systems that protect against engine plumes. The ship quick disconnect arm, now equipped with swivel joints, awaits its end piece, potentially arriving fully assembled. These enhancements are critical for SpaceX's Lunar Starship as they support cryogenic propellant loading for extended missions, including the methane and oxygen subcoolers being relocated from the obsolete tank farm to McGregor for testing. By standardizing tower layouts, such as swapping drawworks and spool positions, SpaceX is building redundancy and protection, reducing maintenance needs, and ensuring the infrastructure can sustain the rigorous testing required for lunar certification. Parallel to these site upgrades, production at the bays is hitting new strides, directly benefiting SpaceX's Lunar Starship program. The rollout of the first version 3 Starship transport stand and the modification of version 2 stands for version 3 compatibility mark a shift toward more advanced prototypes. In Megabay 2, Ship 39, the inaugural version 3 ship has seen rapid stacking, with sections 5 and 6 integrated swiftly, complete with pins and heat shield tiles applied during assembly. This streamlined process contrasts with earlier methods where tiles were added post-stacking, and it promises better thermal protection for re-entry scenarios akin to those SpaceX's Lunar Starship will face during Earth return from lunar orbits. Internal components, like transfer tubes rolled out from Starfactory, are being meticulously installed, feeding gimbaling Raptors and vacuum engines essential for precise lunar descent and ascent. The aft section, spotted outside Megabay 2, features an updated quick disconnect design tailored for version 3, hinting at improvements in propellant management that could extend loiter times on the lunar surface. Meanwhile, Megabay 1 has likely achieved the first fully stacked version 3 super heavy booster, with methane tanks positioned and bridge cranes facilitating assembly. These vehicles are not just test articles. They represent the backbone of SpaceX's Lunar Starship fleet, optimized for higher payload capacities and reusability that will enable cost-effective lunar cargo deliveries and crewed landings. The timeline for these advancements is particularly noteworthy. SpaceX's VP of Launch indicated at the Space Economy Summit that the first version 3 Starship launch could occur as early as January, with a booster rollout for tests in days to weeks. While optimistic, this aligns with the pace at Massey's test site, where preparations for cryogenic proofs and structural tests are underway. Upgrades like the new can crusher cap and reinforced commodities bunker roof, nearly a meter thick with rebar, ensure that version 3 hardware, including hot stage rings, can withstand the stresses of lunar mission simulations. The static fire stand, now with hold-down clamps and shielding, is primed for engine tests that will validate performance for SpaceX's Lunar Starship's vacuum Raptors. These infrastructure and vehicle progresses are more than incremental. They lay the groundwork for SpaceX's Lunar Starship to transition from concept to reality. By addressing bottlenecks in production and testing, SpaceX is positioning itself to meet Artemis deadlines, potentially enabling uncrewed lunar demonstrations soon. However, this rapid evolution also invites scrutiny over safety and environmental protocols as the scale of operations at Starbase grows. As we watch cranes lift steel in Gigabay and hardware parade to McGregor, it's evident that SpaceX's Lunar Starship is no longer a distant dream, but a tangible step toward a multi-planetary future. Hold on to your seats. The saga of SpaceX's Lunar Starship is exploding into high gear, with a whirlwind of launches and groundbreaking commercial ventures that could redefine our lunar ambitions. As SpaceX ramps up its Starship program, these recent missions aren't just routine blasts into orbit. They're adrenaline-pumping previews of the tech that'll propel SpaceX's Lunar Starship to the moon's rugged surface. Imagine boosters roaring back to Earth in twilight spectacles, payloads unveiling futuristic data centers in space, and Elon Musk's bold visions igniting debates about humanity's next giant leap. This isn't science fiction. It's happening now, and it's setting the stage for SpaceX's Lunar Starship to conquer the cosmos. Kicking off the week's high-octane action was the Bandwagon 4 rideshare mission from SLC-40, a heart-pounding display of SpaceX's Falcon 9 prowess. Booster 1091, on only its third flight, thundered skyward, delivering 18 payloads into a mid-inclination orbit that's perfect for real-time Earth observation and weather wizardry. But the real showstopper, that twilight boost back burn at stage separation. a mesmerizing, nebula-like glow that left viewers breathless. Then, in a nail-biting return-to-launch site maneuver, the booster nailed a flawless landing at Landing Zone 2 under the cover of darkness. These precision feats aren't just impressive, they're directly honing the reusability tech vital for SpaceX's Lunar Starship, where every component must endure multiple trips to support sustained lunar operations. As the second stage soared, the drama unfolded with 1 second Merlin vacuum burns tweaking the orbit, building suspense before the payloads deployed. The star of the show, Vast's Haven demo spacecraft, separating in stunning 4K glory as its solar panels unfurled like wings ready for flight. This isn't mere hardware. It's a critical testbed for Haven 1, featuring identical solar arrays, computers, batteries, and impulse space thrusters that could one day integrate with SpaceX's Lunar Starship for hybrid space stations orbiting the moon. With Haven 1's primary structure acing load tests and now buzzing with life support integrations, Vast is charging toward a mid-2026 launch, potentially syncing with SpaceX's Lunar Starship timelines for collaborative lunar outposts. But wait, the plot thickens with Starcloud 1, a fridge-sized powerhouse packing an NVIDIA H100 GPU that shatters orbital computing limits with 100 times the power of anything up there today. Co-founder Philip Johnston's ecstatic post-launch vibes capture the thrill. This satellite isn't just floating tech. It's the dawn of colossal orbital data centers fueled by endless solar power, sidestepping Earth's energy crises. A 5-gigawatt behemoth with sprawling 4 kilometers by 4 kilometers solar panels, assembled autonomously in space. Skeptics might scoff at the hurdles like radiation shielding, heat dissipation, and micrometeoroid threats. But with NVIDIA's muscle and partnerships like Rendezvous Robotics, the impossible feels tantalizingly close. For SpaceX's Lunar Starship, this means expanded commercial payloads. Imagine hauling GPU-laden modules to lunar orbit, turning the moon into a data haven. Elon Musk amps up the excitement, tweeting visions of Starlink V3 satellites morphing into terabit-linked compute nodes, monetizing excess capacity over oceans. Starship's might could deploy 100 gigawatts annually to high orbits in mere years. Mind-blowing. But the real jaw-dropper? Pivoting to the moon with mass drivers launching AI satellites from lunar bases, scaling to 100 terawatts with private billions outpacing government coffers. Quantum computing in shadowed craters? It's on the table, supercharging SpaceX's Lunar Starship as the ultimate delivery vehicle for this lunar industrial revolution. No longer just Mars-bound, SpaceX's Lunar Starship is the linchpin in a commercial lunar boom, blending profit with planetary expansion. The launch frenzy didn't stop there. Wednesday's Starlink Group 681 from SLC-40 hurled 29 satellites aloft, a record mass feat confirmed by VP Michael Nichols, promising more mega packs ahead. Thursday's Group 11 to 14 from Vandenberg added 28 more, but tension mounted with an FAA emergency order halting commercial ops during daylight amid shutdown woes. Could this delay SpaceX's Lunar Starship tests? Undeterred, another Falcon 9 capped the week with Booster 1093's 8th landing on the Of Course I Still Love You drone ship. but testament to endurance that'll echo in lunar missions. Globally, the stakes rose. Ariane 6's fourth flight deployed Sentinel-1D with pinpoint precision. Rocket Lab's Electron nailed IQPS-5 from New Zealand in a flawless cascade of separations, and ISRO's LVM-3 lofted the hefty CMS-03 ComSat, India's heaviest GTO payload yet. These international triumphs underscore the competitive arena where SpaceX's Lunar Starship must shine, pushing innovations like orbital data centers to secure lunar dominance. Yet, amid the exhilaration, controversies simmer. Musk's lunar pivot, dwarfing Mars dreams, sparks backlash from purists, while environmentalists eye Starbase's rapid changes warily. Orbital data centers? Thrilling, but critics decry potential space debris risks and energy ethics. Still, as payloads dazzle and visions soar, SpaceX's Lunar Starship emerges as the hero, bridging today's launches to tomorrow's lunar empires. The countdown is on. Will these innovations propel us to the stars or ignite fiercer debates? Brace yourself. The climax of SpaceX's Lunar Starship epic is unfolding with mind-bending visions that could shatter our earthly limits and spark fiery debates across the globe. As Starbase hums with relentless energy, Elon Musk's audacious blueprints for lunar dominance aren't just whispers in the void. They're thunderous declarations of a new era, where SpaceX's Lunar Starship becomes the gateway to interstellar empires. Picture quantum computers humming in shadowy craters, AI factories churning on the moon's barren plains, and private fortunes eclipsing NASA budgets. It's a high-stakes gamble that could catapult humanity to the stars or ignite backlash like never before. The moon isn't a distant rock anymore. It's the battleground for SpaceX's Lunar Starship revolution. Diving into the heart of these electrifying plans, Musk's pivot to lunar commercialization is nothing short of revolutionary. Forget the red dust of Mars for a moment. SpaceX is going all in on the moon, leveraging Starship's colossal lift to seed orbital data centers and beyond. Envision Starcloud's GPU-packed satellites scaling up to gigawatt monstrosities, their solar wings spanning kilometers, assembled by robotic swarms in zero-G. But the real pulse pounder? Lunar bases equipped with mass drivers, hurling AI satellites into orbit at terawatt scales, fueled by uninterrupted solar power and raw regolith resources. SpaceX's Lunar Starship would be the unsung hero here, ferrying hardware, crews, and propellants for in-situ manufacturing, turning science fiction into stark reality. With private investments potentially dwarfing government funds, this could accelerate Artemis goals, enabling permanent habitats where quantum computing thrives in cryogenic craters, solving riddles that stump Earthbound tech. Yet amid this cosmic thrill ride, controversies erupt like solar flares, threatening to derail the dream. Take the optimistic timelines. SpaceX's VP dropping bombshells about a version 3 launch in January. It's exhilarating, but skeptics howl at the echoes of past delays. Remember the Starship explosions that lit up Boca Chica? Critics argue this hype machine glosses over risks, potentially endangering crews and inflating expectations for SpaceX's Lunar Starship, which must nail uncrewed demos before humans strap in. Environmental alarms blare too, demolishing Pad 1, filling deluge ponds, and piling scrap at Starbase. Activists decry habitat destruction in Texas wetlands, questioning if SpaceX's breakneck pace sacrifices sustainability for speed. Could these lunar ambitions amplify earthly woes, with rocket plumes scarring fragile ecosystems? The political drama adds fuel to the fire. Jared Isaacman's renomination as NASA administrator. After a chaotic shuffle with Sean Duffy, it's a plot twist that thrills SpaceX allies but alarms traditionalists, fearing a privatization takeover. Isaacman's bold vision, infusing NASA with entrepreneurial fire, could supercharge SpaceX's Lunar Starship integrations for Artemis. But opponents warn of conflicts, like rolling NASA into the Department of Transportation. Senate confirmation looms like a meteor shower. Will it solidify alliances or fracture them? And the Mars faithful, they're fuming at the lunar detour, accusing Musk of diluting the multi-planetary mandate. It's not just Mars anymore, he proclaims. But is this strategic genius or mission creep, sidelining the red planet while SpaceX's Lunar Starship steals the spotlight? These clashes aren't mere side notes. They're seismic shifts reshaping space exploration's future. Orbital data centers promise boundless compute, but detractors spotlight debris nightmares and ethical quagmires. Who controls lunar AI? Radiation-hardened tech and waste heat woes could turn triumphs into tragedies, demanding ironclad redundancies that SpaceX's Lunar Starship must master. International rivals aren't sleeping either. Ariane 6, Rocket Lab, ISRO flexing muscles with flawless deployments, reminding us the lunar race is a global sprint. FAA shutdowns, halting daylight launches, a chilling reminder of bureaucratic hurdles that could stall SpaceX's Lunar Starship tests, amid whispers of government staffing crises. But here's the electrifying payoff. If SpaceX navigates these storms, the Lunar Starship could herald an unprecedented boom. Cost-effective cargo hauls enabling lunar mining, habitats sprouting like oases, and commercial ops turning the moon into a trillion-dollar frontier. It's a vision that pulses with possibility. As cranes tower in Gigabay and boosters stack in Megabay, SpaceX's Lunar Starship isn't just hardware, it's humanity's ticket to transcendence. The controversies, they fuel the fire, pushing innovations harder. Will we witness lunar liftoffs that redefine destiny? Or will debates ground the dream? The stars await. SpaceX's Lunar Starship is revving up, and the universe is watching.